So here is the graph of y plus 4 equals f of half. No, we want to sketch the graph of y plus 4 equals f of 1 half x plus 1, given that this is the graph of f of x. So the first thing we're going to do, we're going to rewrite this with the y by itself so we can work from left to right. We're going to take the time to describe everything in shorthand, not write the whole essay. What's the half going to do? What kind of transformation? Horizontal or vertical? Vertical what? Stretch, compression, translation. Stretch. Why? Because we're going to multiply the x by 2. But we're going to just describe first. The next number, working from left to right, is the 1. It's going to be horizontal or vertical. Oh, we all said horizontal and I wrote V? Is that what happened? Okay, sorry guys. Horizontal stretch. Yeah. Whew. He's like, oh man, I thought I was getting this and now I'm totally lost again. I'm sorry. I have power to really mess with your brains and make sure I don't abuse it. Okay. It is horizontal stretch. This is horizontal or vertical? Horizontal. Stretch, compression, or translation? Horizontal translation. And finally, the minus 4, vertical translation. So that's short form without having to write out everything. What kind of stretch? Oh, first of all, we notice that we have a horizontal stretch with a horizontal translation. That's our special note. It has to be written in factored form. So sometimes we would now have to take an extra step to write it again. But this one, can you see that the 1 half is already factored out of this? If it wasn't written in factored form, this equation would have looked like this. That's what it would look like if it wasn't in factored form. But this one is in factored form already, so we're ready to go, and in fact we can be more specific. What kind of horizontal stretch? X is going to get multiplied by 2. What kind of horizontal translation? We're going to go left 1. Down 4. And now we can set this up by taking the points, and there's a point given for us. We've got 2, 0.5 and negative 2, 0.5. And we can do all of our stretches, then all of our translations to figure out where that point is going to go. Also, with any graph that has asymptotes, and they're not labeled on here, so we're going to label them. Can you see that this graph has a vertical asymptote and a horizontal asymptote? One at x equals 0, one at y equals 0. We're also going to look at how those asymptotes change. But first, let's do the points. X by 2. We're going to get 4 and negative 4. The y won't change. We should write above here that's what we're doing, just x by 2. There's only one stretch. We have 2 translations. We need to go left 1, left 1, down 4. So what will that do? That 4 is going to go to 3, negative 4 to negative 5, down 4, negative 3.5, and negative 4.5. Now with our asymptotes, if your asymptotes are starting at y equals 0 and x equals 0, you can still go through. First of all, it says x by 2. Well, only one of the asymptotes has an x. Only the top one. What happens if you multiply it by 2? It's not going to change. Yes? Oh, thank you. -2, -0.5. See how easy it is to forget negatives? Hey, but I remembered it in the end. My answer worked out. Because I had it in my head, the right number, even though I wrote down the wrong number. Yes, and anytime you notice little mistakes on there, yeah, just interrupt. Or if you're confused about why a number should be, you can interrupt. And that's fine. That's great. So when we're multiplying x by 2 with our asymptote x equals 0, it's not going to get affected because multiplying 0 by 2 doesn't change it. But it is going to get affected when we move it left 1. It was at x equals 0. Moving it to the left 1 will change that asymptote to x equals -1. Y equals 0, multiplying won't affect it. But when we move it down 4, it's going to change to y equals -4. Now when we go to graph our new graph, we're going to start with our asymptotes. So now I want to draw an asymptote at x equals -1 and an asymptote at y equals -4. We can plot our points. We have 3, -3.5. And -5, -4.5. With our asymptotes there, we can draw our graph towards our new asymptotes. And we have our graph. State the domain and range of each function. In the first one, your domain is everything except there's an asymptote. Everything except x can't equal 0. Our range is everything except for the asymptote. Y can't equal 0. In our new graph, the domain is still everything, but now our asymptote, x can't equal 1. And it's everything for the y except for -4. Yes, did I not write -1? Wrote 1. Zebras. Thank you. Got a sponsor for the homework here. Questions are 7 and 11. And we're going to take some time now to work on those.